Okay, we're ready to go through the textbook exercises on the laws of indices. So this is exercise 2A. We're going to go through the green questions, so question number 3 to question number 11. Okay, of course, any questions, anything you're stuck on, you can comment in the comment section below. But I will go through all of the questions in as much detail as I can. Okay, question number 3. Of course, it is pretty key that you know your laws of indices for this because it's applying what you know now. So if you need to watch any of the previous stuff I've produced, of course, it is all there for free on YouTube. Okay, on the playlist, sorry. Question number 3 is to simplify this. Right, straight away, if you see a negative power, right, you've got to be thinking, right, your negative power law, which is if you've got a number or a base number to a negative power, okay, you go reciprocal 1 over your number to that power. Okay, so we can see here we've got a negative power. So straight away, I'm thinking, right, 1 over my number, in this case, that is 100, x to the power of 4, okay, and the power that I'm raising it to is to the power of 1 over 2, okay? And we know, okay, that power 1 over 2, right, means you're square rooting something. A fractional power means you're rooting. So if we wanted to, we could write this, right, I'm not going to, but you could write it as the square root, okay, or just the root of 100 x to the power of 4. And we've just seen in the previous video, right, we can now write this. In fact, let's just write it going below, otherwise it might get a bit cramped. So that's equal to, this is equal to this, which is going to be equal to 1 over, you then apply your power, which is a half, to each term of the bit below. So it's going to be 100 to the power of 1 over 2 times by x to the 4, and you're putting that to the power of 1 over 2. So that's what we saw on the previous video where we looked at if you have something like a to the n times by b to the n, so different bases, okay, but the same power, you can write it as a times by b to the power. That is what is going on here. I'm applying the power, okay, which is a half, to each part of my expression. Okay, so then we can go and simplify this a little bit further and say, well, what is 100 to the power of a half means the square root of 100, which is 10, so just 1 over 10, and then we've got this part over here, okay, which is x to the 4 times by a half, timesing those two powers together, it's going to give you x to the power 4 times by a half is equal to 2, so x squared. So we get 10 times by x squared. And that is my first answer, okay? If you want to be a little bit fancy about this, you don't have to write this like this at all. You could, if you want to write it as 1 over 10 x to the power of negative 2, because, right, this bit, 1 over x squared, you can write as x to the minus 2 anyway. Probably the book, I'm going to assume, has written it like this, okay, but either of these are definitely the same thing. Good. Question number 4 is this one. Consider your numerator first of all, and then the denominator, so let's go and do that. So the numerator, we've got x to the power of 2/3, and we're timesing by x to the power of 1 over 2. Okay, laws of indices, timesing with the same base. The base here is x and x. We are adding the powers. So this is using our law. If you've got x to some power m, you're timesing it by x to some different power. You just have to go and add the powers, the indexes. These are fractions. You want the denominator to be the same, otherwise they are awkward to act. So let's get the fraction to be over 6. So that's times this one by 2, times it by 2. That's times this one by 3, times this one by 3. Because then we're going to be getting x to the power of 4 over 6, timesing it by x to the power of 3 over 6. Now this is nice and easy to do. Timesing, add the bases together, add the powers together, sorry, 4 over 6, add 3 over 6 is going to give you 7 over 6. So that is my numerator. So the top of this, okay, is equal to x to the power of 7 over 6, and we are now dividing by, let's write it over here, we're doing x to the power of 7 over 6, and we are dividing by x to the power of 1 over 6. Okay, we're dividing with the same base, we can take away the powers. 7 over 6, take away 1 over 6, is going to be 6 over 6. Okay, so x to the power of 6 over 6, which is the same thing. That cancels to give you 1. So x to the power of 1, or just you can write it as x. Nice question. Okay, that is my answer. Very nice. Good. Question number 5. Okay, again, let's go and consider the numerator to begin with. This is using, again, what we learned in the previous video, which was if you are dividing, right, this is kind of, if we reverse from the previous video, like we have something like a over b, to some power, you can write it as a to the n divided by b to the n. So basically, right, we can apply, so here we're cube rooting, we can cube root each individual term, which is using the law from the previous video. Right, we can apply the power, which is in this case a third, to each term, because remember this up here, this top part, we could, if we wanted to, we could write it as 64, p to the 6, q to the 4, okay, and if you're cube rooting, that's the same thing as doing to the power of 1 over 3. So that is the same thing as this. And then we can apply this power, okay, to each individual term, so to 64, p to the 6, and q to the 4. Let's do that. So we can go and do, first of all, apply that power of a third to 64, so 64 to the third, and then timesing it by, so p to the 6 is our next term, so p to the 6, and apply the power, which is a third, and then times it by your next term, which is q to the 4, and your power is 1 over 3. Let's work through this. What is the cube root of 64? It is 4. 4 times 4 times 4 is 64, so it's going to be 4. We've then got timesing it by, well, this bit here, power laws of indices, you can times your powers together. 6 times by a third is going to be equal to 6 over 3, which is 2. So p squared, we're then timesing it by, again, laws of indices, you can times those together. 4 times by a third is 4 over 3. So q to the power of 4 over 3. Okay, so that is the top part evaluated. But then we've got to divide this by 2q, okay, or 2 times q. And what is 4 divided by 2? 4 divided by 2 is equal to 2. We've just got a p squared on the top and there's no p down below, so we can just write it as timesing it by p. Timesing it by, we've then got q to the 4 over 3 divided by q. And this means q to the 1, okay, but because if you're dividing, I'm going to write over here, right, if you've got q to the 4 over 3, and we're dividing it by q to the 1, you want to have the same fraction bases, otherwise you can't take away the powers. So 1 is the same thing as 3 over 3. So q, 4 over 3, take away 3 over 3, because we're dividing with the same base, is going to be a third. So we're going to get timesing it by q to the 1 over 3. So more simply, it's going to be 2, or I've missed out, sorry, I've missed out a square there, haven't I? Sorry, it's just p squared. There's no p below, so I keep it as p squared. So 2 p squared q to the power of 1 over 3. Good. Good. Okay, sorry, but that should be fine. Okay, hopefully that made sense. Good. Question number 6, we've got express this in the form x to the power of a take away x to the power of b. Now, because you've got two sort of separate parts we want you to write it in, let's rewrite this as 1 over root x take away x cubed over root x. Okay, so let's write this as 1 over, and I like to kind of write the root parts as in terms of indices because we're working with indices here. So x to the half, sorry, root x, this is the same thing as x to the power of 1 over 2. And we can write it as take away x cubed over root x, again, is x to the power of 1 over 2. This means exactly the same thing as this, because, right, if you're taking away with the same denominator, you can write it as one denominator. They mean the same thing. Now, the first part, we've got 1 over, that's using your negative power law, okay, which is if you've got a number to a negative power, you can write it as 1 over that number to the power. Okay, so we can write this as x to the power as negative 1 over 2. So this part is this part over here. And we're just simply taking away, we've got x cubed divided by x to the power of a half, dividing with the same base, take away the powers, 3 take away a half is 2.5, which is the same thing as 5 over 2. So take away x to the power 5 over 2. So you can see we've written it as x to some power a, where a is equal to minus 1 over 2. We're taking away this, where b is equal to 5 over 2. And where b is equal to 5 over 2. Good. Okay, hopefully that's all good. So this is my answer. Okay, hopefully that made sense. Question number 7. Again, we've got a numerator and a denominator. You want to write it as two separate parts. Let's begin by looking at the numerator. And actually, if you spot, this is currently written as the difference of two squares. Right, so kind of something that we should know, hopefully, or that we do need to know, is that if we have something like this, right, a take away b, a plus b, that is the difference of two squares. Okay, and you can write that as a squared take away b squared. So looking at this top part, okay, you could expand it. Sorry, I'm just sort of complicating it a bit. If you wanted to, right, just expand your double brackets, but this makes it quicker. So if we expand these double brackets, you will see, right, that if we go and write 2 take away x bracket 2 plus x, okay, we're going to get a squared, where a is 2, so we're going to get 4, take away b squared, b is x, so take away x squared. So that is my numerator part of this, and we are dividing by this. Now this part down here, I'm going to write this in terms of indices again as x squared, okay, and then we're cube rooting it, so we're putting it to the power of 1 over 3. That means cube rooting. And then we can use our laws of indices and rewrite this as x to the power 2 times by a third is 2 over 3. So overall, we're going to be getting the top part, which we just said was 4 take away x squared, divided by this part, okay, which we said was x to the power of 2 over 3 of 2 over 3. But of course we want to write it as two separate parts, so let's go and write this as 4 over x to the power of 2 over 3 and take away x squared over x to the power of 2 over 3, because of course if you've got the same denominator you can combine it as one fraction, so this means the same thing as this. Okay, but it wants it all to be in terms of a numerator. So how can you write this? Well, you know, again, this is using your negative power law. This kind of means 1 over x to the power of 2 over 3, which we can write as x to the negative 2/3. So with the 4 there as well, it's going to be 4 over 4x to the minus 2/3. So the first part we can write as 4x to the minus 2 over 3, take away, and then similarly the second part, okay, all we're doing here, we're doing x squared divided by x to 2 over 3. Let's consider this up here. So we're doing this part, we're doing x squared divided by x to the 2 over 3, dividing, taking away the powers, so we're doing 2 take away 2 over 3, which is 6 over, let's write it out, so we're doing x to the power 6 over 3, divided by x to the 2/3. I've just changed 2 to be 6 over 3 because my 3's are the same. 6/3 take away 2/3 is going to be 4/3, so x to the power of 4 over 3. So that is, this bit is going to be take away x to the power of 4 over 3. Okay, and unless I made a mistake anywhere, 4x to the minus 2/3, take away x to 4 over 3, I believe is correct. That should be good. Okay, question number 8. This one, right, give your answer as a single fraction. I'm going to begin by, again, right, splitting up into two individual parts because that's, I think, going to be useful here. So I'm going to write it, the first part is 12a b to the minus 2 over 8ab, and then take away 16a over 8ab. So again, of course, right, if you've got the same denominator on both parts of the fraction, you can write it as the same over the same thing. So this means the same thing as this. Looking at the first part of this, okay, we can look at the number part. So what is 12 divided by 8? The same thing as 3 over 2. Okay, so we've got 3 over 2. The a's are going to cancel because a divided by a is just 1, so that's going to disappear. We've then got b to the minus 2 divided by b to the 1. Take away the powers. Negative 2 take away 1 is negative 3. So it's going to be b to the power of negative 3. We're taking away 16 divided by 8 is going to give me 2. And again, those a's are going to cancel, so they go. And it's going to be over b. Okay, and over b I can write as that. I can write the same thing as being b to the power of negative 1. Okay, but I've got to write this as a single fraction. Right, so I'm going to write this a little bit differently again. Okay, I'm going to write this, the first part, as 3 over 2b cubed. So this means the same thing as this. I'll just put the b cubed on the bottom, and you'll see why in a second. I'm going to take away 2 over b, because b to the minus 1 means 1 over b. I can put it over b. So these mean exactly the same thing. Let's get rid of this because I don't want this to get in the way. Right, to write this as a single fraction, that's a pretty key part of this. I've got to have the same denominator for here and for here. Currently they are different. To get them to be the same, right, I can multiply this here by times it by, let's do it in a different color. I can times it by 2b squared, because 2b squared times by b gives me 2b cubed. But to keep this fraction here the same, I've got to times also the top of it by 2b squared. So then the first part will remain the same. It's going to be 3 over 2b cubed. Take away, I've got 2 times 2 is 4. So take away 4, I've got that b squared still there, and it's over 2b cubed, because b times by 2b squared is going to give me 4b cubed. Sorry, 2b cubed. Right, otherwise it wouldn't work, would it? Sorry. Over 2b cubed. And now you can see, which is really important, my denominators are the same. They're the same, which means I can write this as one single fraction. I can write it as 3, take away 4b squared over 2b cubed. Okay, and that's it, because I've written it as a single fraction. It's not split up into two parts, right? This is a single fraction as opposed to this, which is sort of two parts to it, which is not good. Although they mean the same thing, I've got to write it as a single fraction. Good. Okay, I believe we're getting pretty close. On to some wordy ones, right? Let's read these carefully. Okay, an elementary computer program is known to be able to sort n input values in k times by n to the power 1.5 microseconds. So right, just be careful with it. I'm seeing microseconds. We do need to know that 1 second, okay, is equal to 1 million microseconds. Okay, seconds. If you go on to university and you do something like engineering, these are called standard internationally units, right? You'll get really familiar with them. So you've got things like micro, milli, nano. You've got to be able to convert them. So right, that's important. But 1 second is equal to 1 million microseconds. Anyway, observations show that it sorts 1 million values in half a second. So n here is 1 million, because it's saying it sorts 1 million values, and n is the input values. So we can plug that into our formula up here and say we've got k times by n, which is 1 million, which is the same thing as 10 to the power of 6 as an indice, okay, and it sorts it in half a second, because it's telling that it can sort out this in this many seconds, which is it can sort out in half a second, okay, right, and half a second is going to be, so 0.5 seconds is going to be equal to half of a million, which is 500,000. Okay, so that's equal to, it does it in this many seconds. Right, we've got to go and find the value of k. Okay, so we can go and write this as k times by 10 to the power 6. I'm going to write this as 5 times by 100,000, because 100,000 is equal to 10 to the power of 5. I'm going to double check that, but I'm pretty sure it is. 10 to the 5. Good. So k times by 10 to the 6 is equal to 5 times by 10 to the power of 5. I'm trying to find k here. What can I go and do? Let's go and divide both sides by 10 to the power of 6. So then k is going to be equal to 5 times by 10 to the 5 over 10 to the 6. Laws of indices, right. I can go and say, well, 10 to the 5 divided by 10 to the 6, take away the powers, 5 take away 6 is negative 1. So 5 times by 10 to the power of negative 1. And I believe that should be good. Unless I've made a mistake somewhere. I think I have made a mistake somewhere. That's not what I got initially. Right, what have I made a mistake here with? Really, really silly. Right. Sorry. That's pretty silly. Apologies. I've made a mistake really early on. Not major. It's pretty major, isn't it? Because, right, I forgot in the question, right, the formula is I've got to put n, which is this, to the power of 1.5. Okay. So, but very similar working. So that's going to be 10 to the power of 9 is equal to, then this bit here was equal to 5 times by 10 to the power of 5. And we worked through it the same as before. Divide by 10 to the 9, so we're going to be getting 5 times by 10 to the 5 over 10 to the 9, which is equal to 5 times by 10 to the power of -4. Okay, just a little mistake there. I forgot to put this from the formula. But it happens, we make mistakes. That is now correct. Okay, good. Question number 10 is the volume and the surface area of a familiar rectangular shape, blah, blah, arranged by formula. Okay, this V equals to Ka to the power of 1.5, where V is in cubic units and A is in square units. Okay, good. For one shape, A is equal to 81, V is equal to 243, find the value of K, just substituting in our values. So let's go and do that. So part A, we're saying that V is 243, and that's going to be equal to K, which we're trying to find. A is equal to 81, and the power is 1.5. That's the same thing. So 1.5 we can write as a fraction as 3 over 2. Okay, and that's useful because now 243 is equal to K. 81 I can write as fractional power, can be the square root of 81, and put it to the power of 3. Okay, so 243 is equal to K. The square root of 81 is 9. 9 cubed is equal to 729. So K, 729. And then if we divide everything through by 729, divide through by 729, this is going to cancel. No, it's not. Sorry, this is going to cancel. And K is going to be equal to 243 divided by 729 is 1 over 3, which is the same thing as 3 to the minus 1. Okay, so K is equal to that for part A. Good. Part B, let's go and do it over here. Part B, and let's go and put a bit of a divide up over here. Okay, part B, hence determine the surface area of a shape with a volume of this. So we're just saying now that our value of V, this is now our new value of V, and we know that K is equal to a third. So we're just putting it into our formula. I'm trying to find the value of A because we're given the volume. Okay, good. So the volume is 64 over 3. That is equal to, we know that K is equal to 3 to the minus 1. And we've got, we're trying to find the surface area. So we're trying to find, timesing it by A. 1.5 again, we can write as 3 over 2. Now actually 3, I'm going to go and write as 1 over 3, just because it's a bit clearer to see. Okay, 1 over 3. If I times everything through by 3, okay, times the whole equation by 3, this and this are going to cancel. Okay, which is good. So I'm left over with 64 being equal to A to the power of 3 over 2. And then to find the value of A here, right, what's the opposite of putting to the power of 3 over 2? The opposite is to do the power of 2 over 3 to both sides. Okay, so put both sides to this power of 2 over 3, because then these cancel, which is good. And we're left over with A being equal to 64 to the power of 2/3. Okay, and that's going to be equal to, well, the square root, the cube root, sorry, of 64. Then we're putting it to the power of 2. The fractional laws of indices. Cube root of 64 is 4. 4 squared is 16, so A is equal to 16, and the unit is going to be in centimeters squared, I think. Yeah, cm squared. So 16 cm squared is your answer there. Good, good, good. If I zoom out, you can see the full shebang, hopefully. There we go. Good. Question number 11. Is this a square-ended cuboid has a volume this, xy squared, where x and y are lengths. A cuboid for which x is equal to 2y has a volume of 128. Okay, find the value of x. Right, so we're saying that the volume here is equal to xy squared, and we know that the volume is 128. Okay, and we also know that x is equal to 2y, so I'm going to replace this with 2y and say that that's equal to 2y times by y squared. Okay, so then 128 is equal to 2y cubed. Divide both sides by 2 to give me 64 being equal to y cubed. Therefore, y is going to be equal to the cube root of 64, which is equal to 4. So it is equal to 4. Okay, unless I've made a mistake somewhere. Okay, right, so that's good, but it's saying what we're trying to find it. Find the value of x. I've actually found y. Y is equal to 4, so I've got to go and put it back into this up here. Okay, so we know that x is equal to 2y, so x is going to be equal to 2. I know that y is 4, so 2 times by 4, which of course is equal to 8. There we go. Perfect. I believe that is it for this. Good. Okay, hopefully that was useful. So I'm really getting through it quite quickly, but hopefully it is comprehensive enough. And of course, you can always rewind if it's going too quickly, and you can comment for any questions. Okay, thank you.